try to identify where is the product part and where is the chain part. Okay. Alright, so here's an x. Okay, let's identify where all the x's are. Here's the x. To this x, we're multiplying it by 2 and subtracting by 3. That's a very simple operation. So that's one function, 2x minus 3. Okay. And after that, we raise to the power of 4. So this is 1, and that's 2. It's one chain rule. But after that, we don't get another, we're not doing something else to that result. We're done with that. And then we're multiplying it to something else. That's where the product rule comes in. This is the product rule. Okay. Okay, and then of course the same here. X squared plus x plus 1, you can do that using power rule and sum rule. And then there's a, this is a, so it's called out 1 and 2 as well. So there's different one. Step 1, step 2. So if you were to actually punch this in the calculator, right? You guys will like punch this in the calculator. What's the last thing you'll be doing? I don't know if that's actually a good analogy. You figure, you punch it in here, you punch that in there, you plug in, let's say 1 in there, you 2 times 1 minus 3 to the power 4. And then you use, I guess use it times by bracket to the power 5. Bracket, all this stuff in there. Okay, maybe that's not a very good analogy. But what I want you to understand is that this multiplication happens very last. What you have to do is, here are the x's. It's like, you know, I give you guys a teamwork, right? So Taeyong does this, Sungmo does this, and at the end you put it together. So I just want to emphasize, the last thing that's being applied to x is the multiplication here. Does that make sense? So for us, when you differentiate, what's the first thing that we have to do? We have to take care of the product. Okay? So let's take care of the product. Let's pretend like this whole thing is A and this whole thing is B. Okay, this whole thing is A and this is B. Then we get this. A prime B, A B prime. So you get 2x minus 3 to the power of 4. You got to differentiate that and multiply by, okay, plus, leave the 2x minus 3 to the power of 4 alone and differentiate the back part. Okay. Here you get, now you got to differentiate the 4 first. So you get 4, 2x minus 3 to the power of 3, chained by what's inside, which is 2. Okay, so I just taking care of this big square bracket. The derivative of that will be 5, x squared plus x plus 1, power of 4. Okay, and we have to differentiate what's inside. Chain it by what's inside. So it's 2x plus 1. That's it. Now, you should be able to simplify this. Okay, so let's try to clean this up. Okay, what do we have in common? So you said we have two terms, 1, 2. What do we have in common? 1 of 2x minus 3 and 4 of these, right? 4. Factor it out. 2x minus 3, 2x minus 3. You know, I think I'm missing a 4 here, right? Okay, so factor out 3 of them. So that's all gone. There's 1 left here. X squared plus x plus 1. If you factor out, you can factor out 4 of them. So all of these are gone. There's 1 left here. So what's going to be left in the bracket? 8 times by x squared plus x plus 1. 5 times by 2x minus 3 and 2x plus 1. Okay, so you get 8x squared plus 8x plus 1, 5, 4x squared, minus 6 plus 2, minus 4x, minus 3. That's 28 combined with that. Minus 20 plus 8 minus 12x. Minus 15 plus 1 minus 14. Are you expected to do this? Absolutely. If you can't do this, you'll make a ton of mistakes later in the course. Unless I made a mistake right now.
Why didn't you times the 1 by 8?
This one? That's a mistake. So minus 15, that's minus 7 then, right? Okay. Okay, so I mean, earlier in the course, your teacher will say, just stop here, okay? But later in the course, you have to actually set this equal to 0 and set this equal to 0 and solve for x. The only way we can solve it is in this form. So if you can't do this, you will be in trouble.